x squared plus 9. The general form is f of x equal to ax squared plus 9. Sorry, plus q rather. It's plus q. So, if you compare the two, okay, the coefficient a is minus 1. So we can say therefore a is minus 1 for our question. Since a is negative, okay, it means the shape of our quadratic function is going to look like this. It's going to have a sad face. The shape of the quadratic function is going to have a sad face because the coefficient of x squared is negative. So before you start sketching the quadratic graph, you must ask yourself, is the coefficient of x squared positive or negative? If it's positive, then you have a smiley face. If it's negative, then you are going to have a sad face. Okay? So the shape will look like this. Then, after knowing the shape, before you draw, you need to know what is the y-intercept, what are the x-intercepts. Okay? The y-intercept, it is this value. You don't need to calculate it. That positive 9 is your y-intercept. So I'll go to my graph and indicate where 9 is. It's somewhere here. Okay? And then I need my x-intercept. Okay? My x-intercept. Now, since the x-intercept y is 0, it means 0 will be equal to minus x squared plus 9. And then I take this minus x squared to the left. Okay, you get x equal to the square root of plus or minus 9. So you get x equal to plus or minus 3. Okay, so our x-intercepts are going to be here. X is going to be minus 3, and the other one will be positive 3. Okay, so here I'm sketching without a table. Now, if you do a table, remember you are starting from minus 5. What's the value of y when x is minus 5? Can someone tell me quickly? When x is minus 5, go to your table. You go to your table. Tell me. Huh? 15. Negative 16. Okay, I don't want those values. Like, let me just use my shape, my x values. I know my y-intercept. Remember, it's a sketch. Please, it's a sketch. It's not a 100% accurate graph, it's a sketch. So all we need to know is what's the shape of the graph? What's the y-intercept? What's the x-intercept? So I've got that. Then the next thing is for me to use freehand to sketch it. Okay? This requires some practice. Okay? So it will look like that. If you draw it using your table values on your calculator, you get a much better graph which is more accurate. Okay? But when you write tests, right, all you want to see is, did you get the shape right? What's your y-intercept? What's your x? What are your x-intercepts? Okay, so the graph looks like that. Then, for the straight line, okay, it's 3x plus 9. Now, when you want to sketch the straight line, use the dual intercept method because that's the easiest. The gradient intercept method is a little bit complex for most of you. So, any straight line passes through an x-intercept and a y-intercept. So, determine those two. So, if you look at the equation of the straight line, it's g of x equal to 3x plus 9. I need to move a little bit quicker. Right? 3x plus what? 9. So if I want to find the x-intercept, I have to put g of x equal to 0. If I do that, I'll get x equal to minus 3. So my x equal to minus 3 is here. My x equal to minus 3 is here. I hope you are following. If you put y equal to 0 here, you get x equal to minus 3. That x equal to minus 3 is the x-intercept. Then, if you want to get the y-intercept, you put x equal to 0 here. If you do that, you get 9. Okay? So those are your two intercepts. An x-intercept at the bottom, which is this one, and the y-intercept there. Okay? Then you take a ruler. Okay, fortunately I've got a ruler here. You take a ruler, okay? Whenever you enter the examination, make sure you've got a ruler. So you sketch. So you must have something like that. So if you did the homework, you're supposed to get your two graphs like this. Okay? The straight line is very easy to sketch. Find your x-intercept, your y-intercept. Take a ruler, draw a straight line beyond those two x and y-intercepts, and then you are done. Okay? So we're supposed to get that. Yes?
In term 1, you showed us how to find Parabola with the calculator.
Yes.
Can you show us that?
Okay, to solve a quadratic equation using a calculator. Okay, the two graphs intersect where x is equal to minus 3 and where x is 0. These are the 2 points. This intersection, okay, at the y-intercept, x is 0. At the x-intercept, x is minus 3. Okay, so f of x is equal to g of x here, and f of x is also equal to g of x at the turning point. Okay, then 5.2.2, f of x is greater than 0. Right, this one, what does it mean to say f of x is greater than 0? Can someone tell us what you understand by f of x is greater than 0? After what you have done so far, your own studying and everything, what Mr. Chuponda has said up to this point, what does f of x is greater than 0 mean? Right, make sure you pay attention. I'm going to try and make it as easy as possible. Remember I said f of x is y, right? F of x is what? Is y. So here it's saying use your graph to solve for x if f of x is greater than 0. What this means is we want the values of x such that the y values of the quadratic function are positive. Okay, I'm simplifying it now. What this means is we want the values of x such that the y values of the quadratic graph are positive. Tell us what values of x such that the y values of the quadratic function are positive. So to get that, you need to go to the graph. So where are the y values positive? If you look at it, obviously, because of the shape of the graph, the y values of the quadratic are going to be positive above the x-axis. Okay, below the x-axis, the y values are negative. So, which 2 points are key to determine the solution? It's the following points. It's the x-intercept. Okay? Between the x-intercepts, our y values above the x-axis are positive. The y values below the x-axis are negative. Okay? So, we want the values of x from here up to positive 3. So your answer will be, if x is between minus 3 and 3, the y values are positive. That's your answer. It's an inequality. Okay? Now, because we have this greater than sign, no equal sign, you are not allowed to put an equal sign here and an equal sign here. If there was an equal sign here, then you can put an equal sign, then an equal sign. So it means we are excluding the minus 3 and the 3 because at x equal to minus 3, y is 0. At x equal to 3, y is 0. But we want the values of y to be greater than 0. So the minus 3 and the 3 must be excluded. Okay? Then let's move on to the last part. Then 5.3, how does the graph of h of x equal to minus x squared minus 9 compare with the graph of f of x? This one is a very simple one. So 5.3, our f of x is equal to minus x squared plus 9. Our h of x is a new function. H of x will be equal to minus x squared minus 9. So how do the two graphs compare? Both of them, they have this part. It's the same. That is the same. The only difference is we have plus 9 in f of x and we have minus 9 in what? In h of x. How many units are there between positive 9 and minus 9? How many units? How many units are there between positive 9 and minus 9? It's 18. Okay, 18 units. You are at positive 9, which is above the x-axis. Minus 9 is below the x-axis. Okay, so what that means is the graph of h of x, okay, the graph of h of x is a translation of f of x by 18 units downwards. Okay, so you write here the graph of h of x is a translation of f of x by 18 units. By 18 units downwards. Okay? So the graph of f of x is a translation of the graph of h of x is a translation of the graph of h of x by 18 units. Or you can say the graph of f of x is a translation of h of x by 18 units upwards. Are you following? Please don't disturb us, okay? Okay, either you get inside or... Then the last one, give the equation of the reflection of f in the x-axis. Okay, I told you when I discussed reflection that reflection about the x-axis does not change the x values, it changes the y values. So the answer for 5.4, your equation of f of x is equal to minus x squared plus 9. I want you to pay attention because what I'm about to say is very important. Your y values in terms of x, your y values are these ones here. This minus x squared plus 9, it's a y value. When you put an x value there, you get a what? A y value. So, this must change, okay, from being positive to negative or vice versa. So, your new equation, okay, your new equation, we have to give it a name, okay? I'm not going to use g of x because it's already there, or h of x, so I'll call it y equal to. Reflection about the y-axis, sorry, about the x-axis can be given by the following equation: y equal to minus f of x. Okay? If you reflect any graph about the x-axis, the new equation will be y equal to minus f of x. So, where there is f of x here, where there is f of x here, you substitute the f of x by this, okay? By everything inside here. So, our new equation will be y equal to minus x squared plus 9. And the final answer will be positive x squared minus 9. So your equation will be y equal to x squared minus 9. And always remember that the reflection about x-axis is given by that. Reflection about the y-axis is given by f of minus x. This is reflection about the y-axis. So all you have to do is, if you are given f of x, you just substitute it, and you get your new equation. Okay? Remember, before we go, that if a graph has a maximum turning point, if it's reflected about the x-axis, it changes from having a maximum turning point to a minimum turning point. Okay? That's why it looks like that. All right?